Right, so okay, so my existing board, which I made, I actually put some LEDs on as well now, which help a little bit tell me what's going on regarding the current that's going to the exit coil. And my switch works great, but the only problem really is the fact that I need more inductance, I need more delay on the coil, and because it's impractical to actually get coils thin enough on the board, because here's another board with the coil track on there. I'll get it to focus. I've covered it in nail varnish. I've been doing a bit of thinking about this, and I came to the conclusion that ideally what I need is some 1 millihenry chokes, which are cheap. Actually, they're quite cheap to buy, and I can get a bunch of those, about 10 actually, for about £1.40, which is not expensive. So what I'm going to do is I'm going to do an array. So this is my new schematic. So the LEDs are still there, but they act as a bypass on the other polarization of the AC. So they go through, and there's a resistor which is in parallel, so they don't blow up. So the resistor shunts most of the current and voltage across, and only a small amount gets through to the LEDs. So what we're going to do next is there's a trimmer which is there to offset, to adjust the amount of current and voltage that's basically being shunted through to L2 or L1. So by adjusting the trimmer pot, which is 100 ohm, it gets warm actually, there's that trimmer, but it's not burnt out, it's fine. So it basically will basically set it to either have a higher gain on the input. This is the input side, which comes from the generator coil, so we can adjust the amount of power that comes in, which charges up C3, which from C2, which is at 47 microfarad, because you see we need the power to be delivered to the RC, or it's not RC network, this is a LC network, because it's a coil and a capacitor network. So by adjusting the trimmer we can move it so that the power basically, because of the delay on the reactance of L1, it will be fractionally delayed, and it will charge up C3, and as soon as C3 is charged, the power will start to bleed through L2 after a few microseconds of delay, which will charge up C4 and so on and so forth until we get to our output. Now hopefully by the time that the power gets to this point here, even if the voltage has disappeared on the input there, we will still have enough power going through to our exit coil, which is basically L5 now. So I've changed some of the labels on it. So I've ordered some of these little chokes, which are, each one is about 1 millihenry. So if I did some testing earlier on, I have a box of let's see, right, I have a box of chokes and coils in here. Sorry, but it's a bit messy because it's very old. But these particular ones were about, well, they were reading about 6.4 millihenries, but yeah, they're supposed to be 6.8, I believe. But anyway, I got good results when I was testing this, even though I wasn't using a capacitor across it. I got some good results with this. So because it's a 6 millihenry, I decided, right, well, let's get some 1 millihenries and put them in series to basically get our delay from the input. If you add these up, it's basically 1, 2, 3, 4. So we'll have about 4 millihenries, which is probably better because it obviously the capacitors at 4.7 microfarad dual, they're actually non-polar. So ignore there's actually no plus or minus signs on these. So I changed the capacitors because I was annoyed with the electrolytics. I couldn't find a non-polar there, so I just used the polyester ones for the footprint. So what we're going to do instead is basically have this array of in series inductors. Right, so the new layout of the board will be like this. Instead of having the coil on the board, the inductors will basically be situated through here. Sorry, I haven't marked them very clearly on here, so we don't. But the capacitors basically will be there. Oh, I'm looking at it upside down, sorry. The inductors are actually here. And where's the other one? Oh god, I got lost now because it's upside down when I was doing it on the computer. Yeah, actually it might help if I turn the whole thing upside down. I can probably see better. Right. Right, so we've got our capacitors here and here, and an inductor there. I need to make them pads bigger. And we have another inductor between there and there. Another inductor between there and there. And then we feed the tapping points to our little circuit board switch. So instead of having a full set of switch positions, which was 5, I think. No, it was actually... It was actually 9 positions before, so I'm only going to be using 4 positions now. So 1, 2, 3, 4. This one is experimental. I just put a thin track there to the other side, which is basically the opposite side of the capacitors, because I want to see what happens with that. If I don't need it, I'll just cut the track off, whatever. So I thought, well, I might as well put that in, because those are vacant anyway. So this is what I'm going to be etching at some point. I'm going to wait until the inductors arrive first of all, so that I can yeah, just check them out. So I thought I'd just do an update on that. And the output goes from here, these 2 pins, the input's over there, and that, you can forget about that. That's just an extra header in case I want to experiment with the signal that's coming through on here, so I can actually add another stage or something, or I can stick another choke across there, or a capacitor or something. It's just experimental, that part. But the switch will basically be mounted there as normal, and it will rotate. We can rotate it, so basically like that. So it's a different circuit. But it'll be fun, so we'll have more fun with that when the bits arrive. And yeah, I did actually print this reverse, so it's easy to see. So this is backwards. Everything is back to front. Right. So, because it's sometimes easier when you're looking at it upside down, back to front. So anyway, that's all really. It's just a little update on where I'm at. So, more later. Thanks for watching.